In this video, I'm going to take you through the steps involved in inputting data into your calculator, checking out the trend or the graph, and also manipulating that data to form a linear relationship. So for this worksheet that we have here, it's called Graphical Relationships. There are several different examples and sample data, and what we're going to do is check out the original shape and then straighten that line or straighten that curve to a line so we can approximate the equation for that line. So I'm going to skip number 1 because this data looks relatively linear. So I'm going to skip number 1 and go on to number 2, because I can tell just by looking at the data table that this is not going to be linear. Alright, so when I look at this data, I see period versus frequency, and as period increases, frequency decreases, but it doesn't seem to decrease at a linear rate. Just because one variable increases and the other decreases does not necessarily make it an inverse relationship. Since the period increases by, it looks like 0.2 each time, frequency should decrease by the same amount each time in order for it to be linear, and it's not. It's decreasing by different amounts every time. So this leads me to believe that this is an inverse relationship, but the only way to really know for sure would be to graph it. So I'm going to pull out my graphing calculator and go into the stat menu, and we're going to edit the data. So I have to delete out all the old data that I had in there. Looks like I had another problem in there. Just get rid of your old data just by hitting delete. And we're going to type in all of our new data. Alright, so it looks like the period goes up by the same amount every time, which that's going to be the independent variable. The independent variable is always the variable that you, the experimenter, purposely set up in advance, and we want to see how it affects the dependent variable. So we'll type in L1 is going to be period, looks like the independent variable, that'll be on X, the X-axis, and L2 is going to be the Y variable, which is frequency. And right now it doesn't really matter if you completely understand what period and frequency are. We're just looking at data. So later on we'll talk more about what period is and what frequency is, and we'll study those definitely in a lot more detail. So we have our two pieces of data in the calculator. We have L1 and L2, and L1 is going to be the x-axis and L2 is going to be the y-axis. So we just want to graph that to see what the trend is. I'm guessing it's going to be an inverse relationship, but I might be wrong. So we go to zoom and scroll down to zoom stat, or you can just hit number 9 and it'll graph it for you. And the reason you do that again is that the calculator will set up the correct window settings to fit all of your data in the graph. So there's our graph, and definitely is not linear. There's a downward sloping curve, which is an inverse relationship. So I was right. So now what do we do? Well, let's look at some of the questions here. What type of relationship exists between these two variables? We can say that that's inverse. So I'll just type that inverse in there. Inverse relationship. Sketch a graph of this raw data and space provided. So we would do that down here. And this doesn't have to be extravagant. It's just going to be a quick sketch. What term best describes the mathematical shape of this data? Well, we have to go back to our notes on that one. Was it a hyperbola or was it a parabola? I'm going to let you go look that up. What should you graph to produce a linear relationship? Add a column to the data table if necessary. Well, yeah, we do need to add a column to this data table. So I'm going to insert columns. I'll insert it to the left. Alright, so what we have to do is take the inverse of each of these values. So since we know that this is an inverse relationship, and we know that To straighten it, we have to inverse that x value. What we're going to do is use our calculator and start calculating what the inverse of all these numbers are. Alright, so I'm going to do, so I'll clear this out, I'm going to do the inverse of 0.2, so I can just do 0.2 inverse, and that's 5. I'm going to do the inverse of 0.4. Alright, and that's 2.5. Oops. The inverse of 0.6 is 1.667. Inverse of 0.8, 1.25, and the inverse of 1 is 1. So now that I have my new x data, it's not really new data, all I've done is I've taken the inverse of my original x data, I've taken the inverse of that, and now I'm going to plot or graph this data in the calculator again. So I'm going to go back into my stat menu, back into the edit menu, and I can just retype these in here. Alright, so I can type in there 5, 2.5, 1.667, 1.25, and 1. Alright, so when I go back to my zoom settings, zoom 9, oh, there it is, so it's linear. So I have essentially proven that this is an inverse relationship because, wow, my data looks like it lines straight up, and I'm sure I would get a very good correlation coefficient on this one, and we can go ahead and figure out what the equation is for that relationship. Alright, so I'm going to go into back into my stat menu again, go over to calculate, and I want to calculate a linear regression. So I'm going to go to 4, and so there it is. I've calculated the linear regression, and it looks like the slope of that line is 0.99. My y-intercept is very close to 0, and my correlation coefficient is very close to 1. So I'm almost 100% precise, and I should be able to put this down as a very accurate equation and precise equation. So if we go to the next question, which says, what is the equation of the best fit line in terms of x and y? Well, our equation of that line then would be y equals 0.996 x plus 0.006. Oh, sorry, 0.003. 0.003. Alright, so what is the correct equation of the best fit line in terms of the correct variables? Alright, this is different. The variables are not x and y. The variables are period and frequency. And if you remember, we had to take the inverse of our frequency or our period originally. So to rewrite this, we have to flip that upside down. Alright, so instead of 0.996x, we have to flip that x variable back over again. So again, we're not dealing with y's and x's here, we're dealing with periods and frequencies. So we'll call the letter f frequency. So we'll say f for frequency equals 0.996 divided by, instead of x, we're using p for period, okay, plus 0.006. Alright, so essentially what we've done here is we've fix this here. Alright, instead of multiplying by x, we're really multiplying by 1 over x, and x in this case is period. So we have to, when we write this original equation again, we have to undo what we just did by straightening. So what do we do when we straightened? We graph the inverse of period. Well, when we come back to the equation again, we have to write the variable in the correct way again. So now we have f equals 0.996 divided by p, not times p, 0.996 over p plus 0.006. 0.006 is still the y-intercept, and so this function right here will give us an inverse relationship. Alright, so that's one example done for you, or mostly done for you, and you should be able to finish the other examples that are given on there.